Hi, in this video we're going to look at linear regression, and it's just one type of regression. Of course, we know linear is a straight line. We will also look at quadratic and many others. But just to start out, linear regression basically says, is there a relationship between x values and y values, and is it consistent? So classic example of linear regression that doesn't fit perfectly but works often is a grasshopper's chirps per second and the temperature. So I've got this table here. You can see in the first column is chirps per second, starting up at 20, and it kind of jumps around a little bit. And then temperature over here at 88 degrees, there are 20 chirps per second, and so on. So we're going to see, is there a relationship? So you can see 20 is up at 88 degrees, whereas a lower number, say somewhere like 14.4, is 76. So is there a correlation? Is there a connection between these two things? In order to do that, we're going to use Desmos. So I'm going to open up Desmos. I'm going to go hit the plus in the top corner. That's in the upper left corner. And we are going to make a table. We need to enter these values. And I'm going to go ahead and pause the video and enter those now. All right, I've got my data entered. There's a couple of things that I want to point out first. You'll notice at the top of the table is the label x1. There's only going to be one x in a table. And then we've got y1. You can change the color of these points. You can even connect them if that's appropriate by clicking and holding that. But you can also put more than one y. So perhaps you've got another cricket that you want to graph, or some other reason where you would want another y value. You can click up on the next tab, go ahead and put in a y2, and then you can start graphing another set of points. It will use the x in the first column and the y in the second y column. For this one, we just need one. Now, nothing has shown up on my graph because I need a good scale. My x's go out to about 20, so I'm going to adjust this. I don't need any negatives, and I'm going to go out to about 20, 25. My y's are temperature, and so in that case, I'm going to need to go all the way up to maybe 80, even 90. So I need to pinch that one down. And now we'll begin to see the data. At this point, you want to just maybe take a look and say, all right, is anything out of the ordinary? Maybe did I make a typo on this one? 7.2. Is this supposed to be 7.2, 82.6? No, that's supposed to be 17. So let me go find that one, and I'll make that adjustment there. All right, now it all kind of seems to be grouping in together. You could zoom in and see that, yeah, it's fairly linear. It's not perfect, but maybe rarely in real life is it going to be. But we want to try to come up with a line, and Desmos can do it, a line of best fit. So here's the notation, and this is something that you have to type in exactly as I'm typing it in, because you are asking the program, Desmos, to do something. And so in order to ask it, you have to type it in exactly like this. We're going to want a linear equation, y equals mx plus b. We have to use that equation, but we have to change it a little bit, so we are asking the calculator instead of just putting an equal sign. So here's what it's going to be. You're going to do y, and then you're going to put 1, because you are telling the calculator, I want you to use the data in the table that I have just created up above. Then use the ABC button to change your inputs to the keyboard, and you are going to hit the tilde button, which is down at the bottom on the right side, tilde. At this point now, there are two unknowns. We don't know the slope, and we don't know the intercept. So we can put in any letter we'd want. I'm just going to stick with A and B. I know that slope is usually with M. I'm just going to go down the order. So I'm going to put in A. Then I need to multiply by X, so it's like A times X. So I will just put in an X, but then here's the thing, we have to tell it we want X1 from our table. So you have to go to 1, and then plus go get one more letter, B. And now we have the line of best fit. This is the linear regression. This is the line that best represents the data. There are a couple of things that I'll call out down in your equation that you've entered. First, you can see the notation. This is what you need to write down. This is what you need to know how to do. Here is your slope. It's 3.4. So basically every time the temperature goes up a degree, or every time a chirp goes up, the temperature it must be going up 3.4 degrees. And then finally, B is your intercept. So this would be your equation. Y equals 3.4x plus 22.8. And that's what you would want to record if I were asking for a test or in your mixed review. There's one other thing that your teacher will cover a little bit more detail in class, but that's this here, these statistics. This tells you how good of a line it is. This R squared value is at about 0.69, and that kind of says that 70% of the data is accurately explained by this line. And maybe that's not exact, something that we could count over here, but you can see that for the most part, these data points are following the line, but there are some, like this 15.4 down here, that doesn't quite fit the mold. When we go from these 2 points right here, it's going down, when in reality it should be going up. So there are some points that are just not fitting this line as we would expect. And that's just something that you will look at and determine, is this a good fit?